Hi, I'm Dave Watts. Welcome to the fourth part of GSA 200, Searching Databases. In this session, we'll learn about the different options for searching relational database content, the offboard database connector, and one box. We'll also learn how to install and configure the offboard database connector. Databases can take many forms. For our purposes, we're discussing relational databases that use structured query language, or SQL, to interact with data. These databases are typically used for transactional processing, where changes may occur frequently. They contain data in tables, which consist of columns for each field and rows for each record. Individual fields may contain simple values, like strings or numbers, or may contain entire documents as large objects. We call those fields blob or clob data. Databases also typically require credentials to allow secure access. Databases are commonly used in conjunction with content management systems to publish web content. The database may contain the content itself in the form of large objects, or it may contain metadata about the content while that content is stored on a web server. It is with these large objects, either in the database or on a web server, or large text fields, that the search appliance provides great value because it's often costly or impossible to index this data for fast lookup inside databases. In either case, you may want to index database content rather than just crawling the website. In the screenshots shown here, we can see an SQL select statement that returns a result set of rows from the carrier table. Note the URL field, sign up, containing links to documents hosted on a web server. In this case, row data will be added as metadata, and the web document will be indexed. There are two ways the GSA can interact with database content. The GSA can index database content using the offboard connector. This will allow the GSA to treat database data just like any other indexed documents. The GSA can identify relevance of database records for a given search. Each database record will be treated as a single document by the GSA. To fetch records, an SQL query will be used, so these can be records created by joins rather than the records stored in individual tables. However, databases can potentially store many millions of records, and because each record is treated as a single document, the license cost for indexing a database can be very expensive. For this reason, you might also consider having the GSA interact with your data using a one box. With a one box, the GSA won't index your database records, but will be able to send the user's search query to the database and display matching results. Records served using a one box will not count against the GSA license, but the GSA will not be able to apply relevance to them. The database connector is only available as an offboard connector. It uses JDBC to connect to databases, and you'll need to provide your own JDBC driver for the connector. Google has specifically tested the connector with a short list of database servers, but you should be able to use any database as long as it has a JDBC driver. To fetch records, you'll write an SQL query. Any SQL query supported by your JDBC driver will work as long as it returns a single table of records that doesn't contain additional information like aggregate rollup or cube data. The connector will periodically rerun this query to identify new or changed records. Your query should use the order by clause to sort records on the primary key in ascending order. This will help the connector identify new and changed records more easily. When a record is fetched by the connector, one of the following can occur. Row data will be converted to an HTML page using XSLT. Row data will be added as metadata, and a blob, clob, or web document will be added as an HTML document and indexed. In the first case, you can control the transformation of that HTML page by customizing the XSLT. The database connector cannot perform authentication. Use the GSA to authenticate users. The connector, however, can perform authorization if the GSA can perform authentication and send it a verified identity. The authorization performed by the connector is very specific. Relies on the database schema containing an authentication mechanism that can be queried using SQL, rather than on the authorization mechanisms built into the database server itself. In other words, the connector can't use a user's native credentials to log into the RDBMS itself, but it can use the user's identity as a filter in an SQL query. This kind of authorization is very common in web applications, where the application server uses a single database account to access the database itself, but then filters queries using tables expressly designed by the application developer for securing access to other tables, fields, or records within the same schema. One use case for the database connector is simply to index database records without corresponding web pages or URLs. This use case is applied when users previously interacted directly with a database by writing SQL queries themselves. In this use case, the connector will fetch each record, convert it to an HTML page, and build content feeds containing these pages. The default XSLT style sheet will convert the list of fields and values into an HTML table, with the fields as column headers and the values as a single row of table data. When the user runs a search and clicks a link to one of these records, there's no actual web server anywhere to serve the result, so the GSA will be the web server. The link to the result will point to the GSA, and the GSA will fetch that single record from the database to build the page with the latest values, which may be different from the cached page indexed by the GSA. This use case is not very common. Most people don't access database records directly, but instead do it through a web server. A more common use case for the database connector is to index database records that are related in some way with other documents. These documents may be external web pages or stored within the database as well using large objects, blob or clob. In either case, the other fields in the record set returned by the SQL query will be used as metadata for the documents. If the documents are external web pages, the connector will build a metadata and URL feed. If the documents are stored in blob or clob fields, the connector will build a content feed that will also contain metadata. When a user runs a search and clicks on a link to one of these records, it will go to the external web server if a metadata feed was built. If you choose to build a content feed using blob or clob fields, you can specify how they're handled. The link may either go to the external web server, which will fetch the blob and clob from the database, or to the GSA, which will do the same. These screenshots show the difference between a content feed containing the database record and a metadata feed containing the database record in addition to the URL of the corresponding document. Note how the database fields are treated as metadata in the second screenshot. If you want to expose database fields as metadata in the first use case, you will need to customize your XSLT style sheet accordingly. The database connector can be downloaded and installed using the standard connector installer. During the install process, you'll be prompted to specify the location of the JDBC driver you want to use. This driver will typically be packaged as a Java jar file. You should download this before installing the connector. Most database vendors provide JDBC drivers for their own databases. Vendor-supplied or third-party JDBC drivers can potentially be used as long as they are self-contained, pure Java JDBC drivers. These are often referred to as Type 4 JDBC drivers. Once the connector has been installed, you can configure it from the GSA admin console. Choose the appropriate connector manager, then create a new database connector instance. You'll need to provide the JDBC connection URL and driver class name. Both of these can be determined by reading the driver documentation. You'll also need to provide the credentials to allow the connector to log into the database, the SQL query to select all the records to be indexed, and the primary key field or fields corresponding to those records. As mentioned previously, your SQL query should include an order by clause to sort by primary key in ascending order. If your database schema contains a field used to track changes, you can use this field as the last modified date for each record. A single database connector instance can only index records fetched with one SQL query. If you want to index records using other SQL queries, you'll need to create additional connector instances. You can do this using the same connector manager or a different one. If you're building a content feed without blob or clob fields, you can specify an XSLT style sheet. This will be used to build the HTML pages to be indexed and to serve the result on the GSA when the user clicks the link to a result. If you're building a content feed that will contain a blob or clob field, you can either specify the name of that field or a field that contains the URL to display the result through your web server. This field can be a calculated column. If you're building a metadata feed, you can either specify a field that contains the corresponding URL, or you can specify the document ID and a base URL that together can be used to build the corresponding URL. Which you choose here will depend on how you associate URLs with database records within your schema. If the connector will build a content feed and your database schema contains a way to filter records using SQL and the user's verified identity, you can specify an authorization query. This will typically involve one or more database tables to contain authorization information, as described earlier. Your authorization query will use placeholders for username and document IDs. The connector will automatically fill them in to fetch a list of documents that the user is allowed to see. Once you've configured the connector, it should begin building a feed immediately. After a short time, you should be able to view the feed within the Feeds page. Soon after a successful feed, you should be able to see entries within Crawl Diagnostics. URLs for these entries will depend on the type of feed the connector built and how you specified URLs to be created in the connector configuration. If the connector built a content feed, the document ID will be a base 64 encoding of the record's primary. Let's take a look at setting up the database connector. We're actually going to set up two instances of it, one to build a content feed and another to build a metadata feed that corresponds with web documents already crawled by the GSA. So I'm going to start off by going to my GSA very quickly and go to Connector Managers. And as we can see here, we just have the onboard connector manager and no offboard connector managers yet. The database connector always has to be offboard because we need to be able to provide JDBC drivers for it. So I need a machine I can install it on, and I'm connected to a remote desktop. I'm going to install it on this machine, but before I do that, let me go ahead and just take a look at the data that I'm going to index first. That data is in a MySQL server. It's a remote machine. I'm simply going to select all of the data from a single table and take a look at that data. So we have a carrier ID field, name, address, city, state _ prov, postal code, country, phone, and finally we have URL and sign up fields. Now, the URL and sign up fields, one way or the other, we can use those to get the URL. Sign up field contains a fully qualified URL, and the URL itself contains just the page, but since all of those pages are in the same directory, we could take that field and put in a base URL. And of course, each record has a unique value for carrier ID. Carrier ID is the primary key. So that's what our data looks like. So now we're going to set up the database connector. And normally I would download and install this from google.com, but we've already downloaded it onto my machine. Once I've navigated to the directory that contains it, I'll run the executable. Now the install process is very simple. It'll ask me a couple of configuration questions along the way. I'll accept the terms of the license agreement, I'll choose to install single connector type because to get the database connector, it's not available with the bundled set of connectors. I'll choose GSA connector for databases. Now right away it's asking me where the jar file is. So I will browse to the location of the jar I've already downloaded. And again, typically your JDBC drivers will be available as jar files. If I have multiple databases that I want this connector to support, multiple database types, I could add additional jar files here. Now at this point, I'm going to give my connector a service name. I'll give it a listening port, and I'll type in the GSA's IP address. Now the listening port will by default be 8080. If that port's in use, I'll have to detect that ahead of time. And to get the IP address of my GSA, I'll simply ping it from here. I'll click on Next. And I will need to use Java to run this because it is a Tomcat server. So I'll select a compatible version of Java. And then basically just click on Next until I get to the Install button. Then I'll click on the Install button. Now it's going to ask me to log in to the GSA from here. So that it can register itself onto the GSA. It has to have a unique name on the GSA, and by default, that'll be Connector Manager 1. If I skip this step, or if it fails, I'll have to manually register the Connector Manager on the GSA. Now, at the end of the process, it says it was successful. It was able to talk to the GSA. And it also gives me a utility to test that the Connector Manager is up itself. Now, at this point, I can leave the machine that is running the Connector Manager, and I can go back to my GSA. So if I go back to my Connector Manager screen on the GSA, I should now see two entries, Connector Manager 0 and Connector Manager 1. Now, if the registration hadn't worked, I could go here and register it directly. I would, however, have to have entered the IP address of my GSA for this registration to work. So back during the install, when it asked me for the IP address of the GSA, that basically configures the Connector Manager to allow connections from this GSA. Before I configure my connector, there are two things I need to do first. I'll go to Content Sources, Start and Block URLs, and then go to my Follow and Patterns. Go ahead and add a follow pattern. Now this follow pattern basically tells the GSA to accept results from the connector I'm going to set up. So database connector 1 is the name that I'm going to use. If I have multiple connectors, I could make this easy by simply removing the specifics and looking for anything that begins with Google connector. Next, on my feeds page, I'll scroll all the way down to the bottom and make sure that the connector manager machine is allowed to send feeds to this GSA. So my GSA is configured to trust feeds from all IP addresses. By default, when you get a new GSA, it's typically configured to only trust feeds coming from 127.0.0.1, in which case I would need to put in my connector manager's IP address or machine name here. But I'll leave mine set at trust feeds from all IP addresses. So my connector manager is available. Now I can go to connectors. I'll select connector manager 1, click on add. The only type of connector available here is DB connector. And I'll go ahead and call this database connector 1. I'll click on Get Configuration Form. At this point, the GSA goes out and talks to the connector manager. The connector manager returns this form, and now I can enter values. Now, for my JDBC driver class name, because I'm using MySQL, I'm going to enter com.mysql.jdbc.driver. Now, to find that out in the first place, I had to read the documentation that came with the JDBC driver. Java values are case sensitive, so note the capitalization of driver, and of course all of the package path information is lowercase. Next, I'll enter my connection URL. And just as before, to figure out what to enter here, I would have to read the documentation for the driver. JDBC connection URLs begin with the string JDBC, but then everything after that is basically dependent on the specific platform. I'll enter the username and password. And then next it asks me for a traversal query. This query is going to control what data is returned for indexing. So I'm simply going to select everything from the table, and I'm specifying here to order it by carrier ID. In point of fact, I don't really need to do that in this example because it is a physical primary key, matches the physical order of the table, but there's no guarantee that's going to be the case all the time. So you should always order by your primary key when bringing back the traversal data. In the next field, I'll enter carrier ID. Ideally, you'll have some sort of timestamp type data field in your database. That will allow the connector to more efficiently keep data up to date. Now, below here, it asks us how we're going to serve document content. And in this initial case, we are simply going to index the table entirely. We're not going to use any of those URL fields. So we'll simply use a style sheet, and because I'm leaving this field blank, the GSA will use its default style sheet, or rather, the connector will use its default style sheet. So I'll scroll down to the bottom, click on Save. And now I should see that my database connector is live. I've got a green light. So next I can go to my feeds page. I can see that the database connector is in progress. 3 documents so far. So my next step is to wait for that to complete. After a short while, the feed will be processed. Here I can see my database connector completed, 3 documents. Next, I'll go to Index Diagnostics, and simply verify the existence of the documents there. If I click on the cached link for one, I can see the HTML page that the GSA used. The connector builds a page with a single table, and in the header row we have our column names, and then in the body of the table, that one row, we have the actual data. Now I'm ready to run a search. I'll search for the words New Haven. And I can see among the other documents, I get my database result. And if I mouse over it, in the status bar of the browser, I can see that it points back to gsa2.learngsa.com. If I click on it, it sends me to that document. Next, I'm going to show the metadata that's associated with this page, and right now there really isn't very much. If I simply return to my search results and remove the proxy style sheet parameter and add get fields equals asterisk, for my third result, I can see that there are only 2 pieces of data displayed as metadata, the display URL and the MIME type, which were provided by the connector's feed. Next, I'm going to create a second database connector instance. In this second connector instance, we're going to build a metadata feed. So this one built a content feed. It indexed each row as a separate document with no special metadata. The one we're going to add now is going to index metadata, all the fields as metadata, and build a URL. I'll call this one Database Connector 2. I'll use the same values for JDBC driver class name, connection URL, username and password. Same SQL query, and same primary key field. But now, instead of using a style sheet to serve document content, I'm going to choose document URL field and then simply type in sign up. Remember, the sign up field contains the fully qualified URL. I'll save this. Verify that I get a green light. Go to the feeds page and notice that the second database connector, metadata and URL feed. If I go back to Index Diagnostics, the documents in question are actually on athens.learngsa.com. So these are the 3 documents that were indexed, and the fields in the database are now applied to these as metadata. We can actually see the metadata exposed right here. These are my database fields. Now, of course, the document itself does not literally have the metadata within it. So it does have some metadata, but not the fields from the database. Again, if I go back to Index Diagnostics, you'll notice that I get both the fields from the database as well as the fields that were literally embedded in the document. Now, if I go back and rerun my search for New Haven, scroll down to the bottom, you'll notice that I have this sign-up sheet. So it is there. And once again, if I remove the proxy style sheet parameter, and replace it with get fields equals star, and view my last result, all of the metadata is present. This concludes our 4th presentation, Searching Databases. Thank you for watching, and make sure to watch the other GSA 200 presentations.